Business agility shouldn't come as any surprise. Any of you who heard Cal's talk last night would know that what we have to do so often is see how our products and services are reacting, how our clients are reacting to them, our customers, and pivot and change. And so we need to be able to run experiments. And this is what I want to talk about in the context of business agility, is this virtuous cycle. But it's important to start with a testable hypothesis. What is it that you're really trying to achieve? What is the outcome you are looking for? And happy customer, well, that's a wonderful goal, but you can't measure a happy customer. You have to measure customer satisfaction. You have to measure cart abandonment, things of that nature. So you need to start with something you can actually test. And then you want to use a process of continuous and experimental design, looking at how it is that your customers are going to respond to this product. And then you want to be able to deliver fast and reliably and safely so that you can have these small experiments rather than one big experiment. And most importantly, then you want to measure. If you added up all of the dollars that should have been saved across all the business cases in any of your organizations, they would probably dwarf the GDP of the company. But we never measure. We never actually go back and measure. And then, of course, we want to repeat this because the whole purpose is to be able to run lots and lots of experiments because you never know where that next good idea is going to come from. And why should you care about this? Well, business model lifetimes are shrinking. It used to be if you got into the Fortune 100, you were going to be there for a long time. The fundamentals of how our organizations make money are changing radically. And we're actually pretty good now at dealing with changing business requirements, in adapting the way we interact with our customers. We spent a long time in the agile software development world figuring out how to deal with requirement change. But what about ecosystem change? What about when Docker dropped into our ecosystem? And even if you don't use Docker, you need to think about it. How are we going to cope with some of these fundamental changes in our ecosystem? And when you think about the job of an architect is very often to plan. And when I started in this business, it was perfectly sensible to have 5- and 10-year technology roadmaps. The iPhone is only 11 years old. We cannot have those kind of roadmaps now. So how are you supposed to plan at all when we have constant change? How are you going to figure out for your organization and for your product or service what is the sweet spot in this changing technical ecosystem? How are you going to find that spot, and how are you going to remain able to alter your position as things change in that ecosystem? And that's what we're talking about with evolutionary architecture. Evolutionary architecture, the word is very precisely determined. This is not an adaptable architecture. We're not talking about, I'm going to be able to configure things and I'm going to figure out where all the change is coming from and be ready for it. Because you can't guess where the change is going to come from. Rather, you have to figure out what constitutes a good architecture for your organization, for your application, for your domain. Because there is not one good architecture. What you need to focus on changes. Cal actually talked about this last night as well. You may not, out of the box, want to worry about scalability because you don't know if anybody's going to buy your product. Doesn't matter if it can scale to 1 million users if only 2 or 3 use it. So think about what constitutes good. So here's our definition of an evolutionary architecture. An evolutionary architecture supports guided incremental change across multiple dimensions. And each one of those key phrases is important. But probably the most important is this guided principle. Because what we're talking about here is you have to decide for your situation what you're going to focus on. Now, this is inspired by evolutionary computation, things like genetic algorithms, where we have a fitness function that defines what constitutes good. And it guides, then, the solutions that are developed in order to solve that problem. Here's a particular example. I was at a conference, and a group of engineers was developing or presenting a genetic algorithm to design a new airplane wing. And they used aerodynamic characteristics as their fitness function. And then they showed their design to the aeronautical engineers, and they all said, your program has a bug in it, because this wing had all of these weird scaffolding and these weird things jutting out all over it. But they actually did the analysis, and it was aerodynamically efficient. Perhaps difficult to manufacture, perhaps couldn't withstand airplane flight, but that was their fitness function. This is what we're talking about then for architecture. We want to design architectural fitness functions, which tell us how close we are to achieving the objectives that we want. Precisely, not maintainable, but a specified code quality or specified architectural coupling characteristics. So this is what we mean by guided. Our architectural decisions are going to be guided by these fitness functions. Now, these fitness functions are not anything new. And there are different kinds of fitness functions. And I won't go through all of these, but I want to focus on two. The first is manual versus automated. It may be that some of these you don't want to automate. But to the extent that you can automate these, you radically shift what constitutes architectural governance, because you no longer have to do a code review to look at these things. So to the extent possible, you want to automate these. And then I want to talk briefly about domain-specific, because people get confused about this. When Neal and I talk about this, one of the most common questions is, where can I download the fitness functions for my banking application? I said, well, can you download your story list for your banking application? These things are specific. But there are some things, like, for example, HIPAA requirements or GDPR requirements, that you could maybe argue would be domain-specific. And these fitness functions are things we've seen before. Here are some examples. A static analysis that looks for cyclic dependencies. Consumer-driven contracts that are looking at an integration point. The Simian Army is one of the more interesting ones. This is a continuously running architectural fitness function that ensures that no applications get into that ecosystem that do not respect the architectural requirements that have been established for it. And no architectural governance has to go on to look at things like RESTful endpoints being properly configured, because the doctor monkey will toss it out if it ever gets in. So you don't have to think about it. Fitness functions like these automate a lot of the governance processes so that we can now have architects focus on real problems. Like, what do I do if there's an incompatibility between two of my requirements? Maybe scalability or response time and data staleness. So that's what I mean by guided. What about incremental change? There are two aspects to incremental change. One is the application. How do I shift out my application? How do I release new functionality? Maybe you deploy a new service and you monitor the old one, and then you can take the old one out of your ecosystem once nobody's using it anymore. But we need to think about what techniques we are going to use for incremental change at the functional level. But we also need to think about it from the operational level. And this is where one of the critical enablers of evolutionary architectures come into play, and that is the discipline around continuous delivery. When I first started talking about evolutionary architecture, people would actually come up to me at the end of the talk and whisper very quietly, "Don't you think you're being professionally irresponsible to advocate for something as radical as an evolutionary architecture? The architecture is the foundation. You cannot change it." Well, no, you have to be able to change it. But you need to know that you're changing it as safely as possible, and the discipline and the rigor of the automation that comes with continuous delivery provides this foundation to allow us to do things as radical as changing out the fundamental characteristics of our architecture. And then across multiple dimensions. As architects, one of the most common words that we will use is trade-off, because here are all the things that we might have to worry about, all of the illities. But these things very often are mutually inconsistent. You cannot both maximize performance and maximize security. If you're going to increase security, you're going to do things like do heavier encryption, which is going to require more compute, which is going to degrade your performance. That doesn't mean you can't get high security and high performance, but you can't maximize both. You have to decide in that particular situation what is the right trade-off. What we're talking about in evolutionary architecture is adding an additional illity to this list, which you're going to prioritize like the others, and it's evolvability, our ability to change whatever aspect of our architecture we have to. If you have a simple enough application, you're probably not going to prioritize evolvability, because you're just going to throw it away and rewrite it. But if you've got a critical system within an enterprise that has those thousands of tools and millions of customers, you might want to be able to change rapidly regardless of what happens. And as, again, Cal mentioned last night, many of our customers now are coming in with expectations of consumer-level interactions. So you as a bank or an automobile manufacturer or a retailer need to respond to what people like Netflix do, or Twitter, or Facebook, because that's where the expectations of your customers are now coming from. And you don't know who's going to come up with the next radical idea. So evolvability needs to become a first-class citizen. And within the context of evolutionary architecture, what we are trying to do is determine, of all those illities, which ones do we care about, and then have the fitness functions that ensure that we're maintaining those characteristics that we worked so hard to get in the first place. So what are some principles of evolutionary architecture? I could do an entire presentation on many just of these individual principles, but let's talk about them. We want to talk about when we make decisions. We want to talk about the process of software delivery. We want to talk about how things integrate with each other. I work for ThoughtWorks. We always have to talk about testing, but there are some interesting things we've learned about testability. And then, of course, there's the pesky people problems. We have to think about how we actually organize ourselves. So let's start with this principle, the last responsible moment. We want to delay our decisions as long as possible, because then we'll know more. We will have a better view of what the landscape is. And we will be able to respond to the highest priority requirements at that particular time. And your fitness functions and that work that you did to figure out what's most important is how you're going to know what those priorities should be. And next, we want to architect our systems and develop our systems for testability, or for evolvability. And one of the critical components of this from a development perspective is how easy is it to understand the code. So we're going to look for software quality metrics, appropriate coupling between components, because you cannot change something you do not understand. And so we're going to focus on that. From an architecture perspective, we're going to focus on how closely does our system map the way the business talks about how it makes money. The closer you are to a conceptual model that corresponds to how your business users think about technology, the easier it's going to be for you to respond to the requests they make. As technologists, we often get into trouble because we think about our IT asset from the perspective of the systems. The business doesn't care about the systems. The business cares about customers and orders and supply chains and routes and all of those things. Postel's law. We need to think about how systems are integrating with each other. And there are two sides to this. As a receiver, you want to be as generous as possible. Asterisk, make sure you don't expose yourself to security holes. But if all you need is a zip code to do some kind of geotagging, don't validate the address. Because then, if somebody changes the format of the address, you're going to have to change, even though you didn't have to. There is nothing in evolutionary architecture that will protect us from all changes. We just want to make changes only when we have to and have them be as simple as possible. The other side of Postel's law is be very cautious about what you send, because as soon as you put something out there, you don't know who's going to start relying on it. And so you want to be sure that that's something that's pretty fundamental so that you're quite certain you're not going to have to change it. Now, the other thing to think about with Postel's law is people often think about this in just messaging applications, but this applies to all other forms of integration in our systems. We are still, unfortunately, doing far too much integration through databases. And we have the same kind of problems where you can't change things because something is too tightly coupled to a particular database. So think about how you are coordinating and integrating your activities amongst the different components. And then what about testability? And one of the things that we've found is that if you think about how hard it is to test something, you are likely to end up with a clean architecture. Thinking about testability is going to steer you away from a lot of the bad architectural choices because it's just too hard to test. If you think about or developing a test that says do this and then this, and you can't think of any kind of unifying concept that takes all of those steps, chances are whatever you're trying to test is doing too much. If there isn't a single unifying concept at some level of abstraction, that thing is just not well thought out. So think about testability, and you're going to end up with a cleaner architecture. And then there's Conway's Law. And basically what Conway's Law says is any system an organization builds is going to reflect the communication patterns of that organization. I often look really smart when I go into clients, and I sit there at lunch, and then in the afternoon, I tell them that integration is almost certainly broken. They say, how can you know that? You haven't even looked at our systems yet. But I watched the tech leads, and they walk past each other like this. If people don't talk, the systems will not talk. And so when we're thinking about how we want to build our systems, the organization that builds it has to reflect what we're trying to achieve. Conway's Law is always going to win. So use what we call the reverse Conway maneuver. You want to get to a particular system, a particular architecture. Change your organization, and the system will follow. It actually works. So what about techniques? How would we go about actually doing this? Each one of these techniques I'm going to talk about, you could probably have a day, if not a week-long workshop, but it's worth highlighting them. Probably the single biggest enabler for evolutionary architecture is this notion of database refactoring. And when I think about the history of Agile and all of the different roles and how people complained about, oh, well, it's all right for these people to do incremental, but I need to have something well thought out, whether it be user stories or user experiences. The DBAs of the world had the best claim to this because data migration is hard. It doesn't sound hard. Copy data from this format to that. What could possibly go wrong? But it always does. This technique of database refactoring allows you to break down mass migrations into something that makes it far easier to migrate. The book is actually called Refactoring Databases, and its subtitle is Evolutionary Database Design. We've been telling the authors they need to republish the book and just switch the title and subtitle. Choreography. This comes into play a lot when we start to think about, for example, microservices architecture. And this is as distinct from orchestration. In orchestration, you have a conductor who is in charge of everything. And that simplifies a lot. But what happens if the conductor falls off the stage? Everything stops. In choreography, the choreographer isn't on the stage during the performance. They've laid out the vision. Each one of the individual performers know what they're supposed to do. But you're asking a lot more of those performers because they have to decide what to do if something goes wrong. And there are failure modes in a choreographed system that simply can't happen in an orchestrated system. So this is not something you're going to want to use all the time, but it's one of the techniques that makes it easier to switch out individual components. Contract testing. You also saw this as one of the fitness functions. But this is an excellent way to maximize the amount of parallel work that can go on. We know that the more individuals have to communicate and have dependencies, the longer things take. What we do with contract testing is I know what all of you are assuming about my system because you've given me tests, and I run those tests. And then I ignore you completely, and you ignore me completely, until such time as one of our tests break. And that's the trigger for the conversation, because that means I'm trying to make a change that one of you can't handle. And so we go through our negotiation and come up with a new solution. And we never talk to anybody else, because as long as their tests haven't broken, what we are talking about isn't going to affect them. So everybody can cheerfully ignore each other, make whatever decisions are necessary for them to achieve their objectives, and pay no attention to anybody else. That's what you want to get into a position of being able to achieve, because that allows each group the ultimate flexibility. I mentioned this before, but I want to reinforce it. There is a case to be made that if you do not have the rigor and the discipline that is required to support continuous delivery, you should not be trying to do some of these things. If you don't know that you can safely deploy your applications, if you don't know what your servers look like specifically in all of their different instances, if you don't know those things, you probably don't want to try this. However, like continuous delivery, making just small incremental progress can have an enormous impact on your risk profile and your ability to deliver. Now, I want to run through some architectural styles, because there are some people who assume that microservices and evolutionary architecture are one and the same. And that's not true. Part of what we're trying to talk about is how you can evolve different kinds of architectures. But the big ball of mud is never going anywhere. There's not a whole lot you can do except try to clean up the big ball of mud. It's not very evolvable. But in many situations, a well-structured monolith gives you a lot of the flexibility that you can get with many other architectures. You still don't have a whole lot of deployment flexibility. It's a monolith. They're going to deploy it all together. But your ability to make significant changes is significant in a well-structured monolith. Emphasis on the well-structured. You're probably still going to not have the degree of flexibility on your technical architecture that you might have, say, in microservices, but you still have a lot more than people will often give monoliths credit for. Layered monoliths are not quite as good because these tend to give you the flexibility for a particular architectural layer. But when you're doing any kind of functionality, you're still touching all of those different layers, and you don't have any more ability to make changes from a functional perspective. So you've got very good flexibility as long as it lines up with your layers. But if it doesn't, you may not be in any better situation than you are with the big ball of mud. I always feel a little uncomfortable about microkernel architectures because they do allow a tremendous amount of flexibility, but they're getting very close to that edge of, I actually know where all my change is going to come from, and so I'm going to be ready for it. But still, again, within the construct of that microkernel architecture, you actually have a significant amount of evolvability in that architectural style, and you will have, in fact, more flexibility from a technical architecture perspective than you do in, for example, a layered monolith. But from a purely evolutionary architecture perspective, you have the maximum amount of flexibility with microservices. That does not mean you want to use them all the time. If you don't need that level of flexibility, and as I said earlier, evolvability is one of those things you have to prioritize. If you don't need it, you want to be careful about assuming this level of complexity. Microservices are not for everyone. So hopefully it's pretty clear how you would do this if you were starting from a green field. But what if you're starting from a brown field? I suspect the vast majority of us are working with systems that have been around at least for several years, if not a few decades. So what do you do in that situation? Well, you still follow the same basic approach. You still want to think about what are the architectural characteristics that are most critical to success in this context. Define that fitness function across the different entities that you care about. And then select a dimension that you're most worried about. Notice I did not say that you expect to change, the one that worries you the most. Maybe it's your mean time to recovery. Maybe it's your scalability. Pick the one where you feel most exposed, most vulnerable, where you think the system is furthest away from what you actually need. And then start working on it. If you've got that fitness function, you can start to focus on those areas of the system that matter the most, that you're most concerned about. Monitor those trends. If you're very far off, you're probably not going to want to break the build immediately, but you still want to track it. If your performance isn't where you want it, just monitor it so that you can continue to improve, and you can demonstrate to your organization that you're continuing to improve. Monitor, adapt, and repeat. And once you get to where you want to be for that particular dimension, go back and pick the next one. I would love to be able to say no bad code should ever exist on the planet. I was an academic, and that's probably how a lot of academics feel. However, I'm a realist. We may have to accept that some of these things are not going to be how we want them for a time, but we at least need to know where we're exposed. So monitor these things and continue to try to improve. And one of the important parts of this is because you're monitoring this, you can look your boss in the eye and say, it's not going to get worse again. The money you're investing to allow us to clean this up, you're not going to have to invest again because we're watching it now. And that, in my experience, is critical to allow these remediation efforts to take place. So you can make small steps to make your architecture more evolvable. And this will help you understand just what it is you need to do to be able to respond to the demands of your bosses and your customers. Thank you very much.